Hello everyone, my name is Vivek and today I'll be presenting my mini project on quantum computing using Qiskit and Google Colab. In this project I explored how quantum computing program differs from classical programming through experiments, superposition, entanglement, detach, Zosha algorithm and Grover's search. I've compared how the same ideas would look in ordinary code versus a real quantum circuit and how quantum mechanics given a unique result. Let's start with the quick difference in a classical computer. Information is stored in bits, which can be either 0 or 1 at a time, and a quantum computer uses a qubits, which can be both 0 and 1 simultaneously. That properly is called superposition. When two qubits interact, they can become entangled, meaning the state of one instantly affect other even if they are apart. Another important idea is the interface. Quantum states can add, cancel each other, allowing us to keep the correct answer and suppress the wrong ideas. So in this video I'll demonstrate how properties appear in actual Qiskit code. So first is experiment 1, which is a superposition. I'll be showing you the code like in few minutes. So let's first talk about the experiment 1, which was the superposition, that how a quantum computer works. So we'll use quantum coin flip. My first circuit demonstrates superposition, a quantum version of flipping a coin. In classical Python, we might write random choices 0, 1, which gives 0, 1 randomly through an algorithm. In quantum computing, I'll start with a qubit in state, apply a Hadamard gate, and then measure the Hadamard gate, puts the qubit into an equal mix of 0 and 1. When I run the circuit multiple times, say 2048 slots, the historical shows roughly 50% to 0 and 50% to 1. This randomly is not algorithm, it comes directly from quantum probabilities. So this is a demo, proves that qubit can exist in multiple states at once until it is measured. So now let's talk about the experiment 2, which is the Bell state. Now let's start it. In the second circuit, I'll create an entanglement using two qubits. First I'll apply a Hadamard gate on the first qubit to create a superposition, then on a C0 gate to link it with the second qubit. When I measure both, the result are mostly 0, 0 and 1, 1, or it can never be a 0, 1 or 1, 0. This means qubit collapse together if one is 0 and other is 0, if one is 1 and the other is 1. This correlation cannot be explained by classical rules, so it is perfect example of quantum entanglement. The same phenomena Einstein called spooky action of a distance. At a distance. So experiment 3, Zosha's algorithm. Next I'll implement a simple version of a Zosha's algorithm. The goal is to determine whether a hidden function is constant or balanced. A classical computer needs to test the function twice, for 0 and 1, to be sure. In my quantum circuit, the input qubit is placed in superposition, the oracle is applied once, and interface in the final Hadamard steps gives the answer immediately. When the function is constant, the measurement is always 0. When it is balanced, the result is 1. So in a single run, we know the type of function that is really quantum speed up achieved through our interface. So what's the difference between classical versus the quantum? Classical code executes one path at a time, while quantum circuit explore all the paths simultaneously through superposition. Classical correlation is predefined, but quantum entanglement is fundamental and non-local. Classical algorithm rely on logical and iteration. Quantum algorithm uses interface and amplitude amplification. Outputs in classical computing are deterministic. In quantum computing, they are basically probabilistic and seen as in histograms and measurement results. So what is the basic conclusion? In the conclusion, this project demonstrates the basic principle of quantum computing using Qiskit. Through the 4 experiments, we saw superposition, entanglement, quantum interface, and amplitude amplification in action. Thank you.